Hello students, welcome to Misostudy and welcome to my class. In my last lecture, I was discussing about the questions for your upcoming board examination. I have taken the chapter that is aldehyde, ketone and carboxylic acid. Today I will discuss the chapters amines. Clear? I have taken few questions from this chapter and definitely it will help you a lot. So let's start the question answer round. Read the question carefully. What is given? That is, write the chemical equation for the following reaction. What is given here? That is reaction of ethanolic NH3 with C2H5Cl. Okay, this NH3 combined with C2H5. It can be written like this: CH3 CH2 Cl. Okay, yes. Now what will happen? As we know, this will have more electron density, so C will be move here, and this, due to lone pair of electron present in nitrogen, this will come here. So it can be written like this: NH2H. Okay, yes, NH2 minus and H plus, and Cl minus CH2 plus. This is a simple. As I told you earlier, if you have a command to write plus and minus, then you can get each and every output. Now this NH2 will come here, so we get the first product CH3 CH2 NH2. Again, it has a lone pair of electron. Okay, and the byproduct, what is getting? CHCl. Now again, this is treated with CH3 CH2 Cl. Same case will happen, that is, this can be written like this: NH and H. Clear? We can write like this: CH3 CH2 NH and put here N. Now again, it will acquire negative sign and it will acquire positive sign, and it will acquire negative sign, it will acquire, so it will come here. So the next product, I am moving here, check it out, that is CH3 CH2 whole twice NH. Am I right? Yes. Now again, it is treated with CH3 CH2 Cl. Similar, it can be written like this: NH, H plus, this N minus. So again, this one minus, this plus, so it will move here. So finally what we get? CH3 CH2 whole thrice N. Am I right? Yes, whole thrice N. Now again, when it is treated with one more mole CH3 CH2 Cl, it forms CH3 CH2 whole 4 N plus Cl minus. This is the final product, CH3 CH2 whole 4. Is it clear? Let me check once: CH3 CH2N and CH3 CH2N plus Cl minus. Okay. Now the next one is ammonolysis of benzyl chloride. Okay, and reaction of amine so formed with 2 mole of CH3Cl. Now let's move to the B part. What is given in B part? Listen carefully. Ammonolysis of benzyl chloride C6H5Cl when treated with NH3. Okay, what we get here? Similarly, this one negative, this one positive, then we will write here NH2H, but here we will get the product NH4Cl, not HCl. Okay, byproduct. So the first product here, C6H5NH2. Clear, my friend? Yes. And the byproduct will be NH4Cl. Okay. Now what given? Ammonolysis of benzyl chloride and the reaction of amine so formed. This is the amine formed with 2 moles of CH3Cl. First of all, it is treated with 1 mole of CH3Cl. Then what will happen? We will get C6H5NHCH3. Clear? Yes. Again, when it is treated with 1 more mole of CH3Cl, it will form product C6H5NCH3 then CH3. This is the final product. Clear to you? Yes, sir. Now, I am rubbing this part. I am going to rub this part, and let's move to the next question. Now, what is the next question? Write the chemical equation for the following conversion. How to convert? Okay. It is given here CH3CH2Cl. Okay, you have to convert it into CH3CH2CH2NH2 chloride into amine. How to convert it? That is, you have to convert this Cl into NH2. Okay, let me do it again. First of all, we have to increase 1 more carbon. Okay, when it is treated with KCN, then what will happen? There is a, again this one is plus and this one is minus, this one is plus and this one is minus. K will come towards Cl, it will form KCl, and the product where CH3CH2CN. Okay, CH3CH2CN. Again, when it is treated with reduction LiAlH4 or H2Ni reduction take place, or you can write H2Ni. Okay, then what is the product we obtain? We product this Cn will be converted to CH2NH2. So the product will be CH3CH2CH2NH2. This is a simple method of conversion of alkyl halide to amine. Now the next one is the B part. What is the B part of the question? Is given C6H5CH2Cl. Similar question, C6H5CH2Cl benzyl chloride. You have to convert it into C6H5CH2CH2NH2. Clear? Now look at, here is the addition of 1 more carbon. So first of all, we have to increase the number of carbon in C6H5CH2Cl. What will happen? Right, C6H5CH2Cl treated with KCN. Again I am repeating, C6H5CH2Cl is treated with KCN. What is the product here? We will get the product C6H5CH2Cn. Am I right? Yes, there is a release of KCl take place. Now again reduction take place in presence of LiAlH4 or NaBH4 or H2Ni. Now this Cn will be converted to CH2NH2. We know this. Now the product will be C6H5CH2CH2NH2. This is the final product, C6H5CH2CH2NH2. Now the next one is how to convert benzene into aniline. Now the question is, this is the benzene, okay sir, and you have to convert benzene into aniline. Benzene into aniline. Now tell me how to convert. This is a simple conversion, benzene into aniline. How will you convert? And the second one is benzene into an diethyl aniline. I am leaving this question for you. I am giving you 30 seconds to think on it. This is a simple conversion and you have to focus on this. Clear? Now tell me how to find benzene into aniline. It's very simple. Now what have you done? This is simply benzene. When it is treated with HNO3, nitration take place, H2SO4, that is the process is called nitration. Okay my friend, yes, nitration, that is it will give nitrobenzene. Yes, this is the nitrobenzene. Further the reduction, what I am telling, further the reduction will give, the process is reduction, will give you aniline. The product is aniline. This is 1, 2 and 3 aniline. Clear? Now the next one is benzene into N diethyl aniline. How to find? Simply we will start this from aniline. First of all, benzene will be converted into aniline. Okay, now this aniline, when treated with 2 moles of CH3I, what I am telling, 2 moles of CH3I, we will get N dimethyl aniline. That is like this. N, this is the benzene ring, that is N diethyl, CH3 and CH3, N dimethyl aniline. Clear? This is a simple method. First one and second one I have done all the thing. First of all, convert it into aniline. Then when aniline is treated with 2 mole of CH3Cl, that, or you can write here CH3I also, then you can get N dimethyl aniline. Okay, now I am going to rub this part and let's move to the next question. Next question is 67. Arrange the following in decreasing or increasing order of basic strength. First question, tell me, is given C6H5NH2, okay, then C2H5NH2, clear, C2H5 whole twice NH and NH3. Now tell me which one is more basic and which one is less basic. Okay, now if I check C6H5NH2, as we know C6H5NH2 there is a lone pair, but the delocalization of the lone pair of electron in nitrogen atom take place over the entire benzene ring. Due to this reason the electron density decreases. If the electron density decreases, then it will have less basic character. So aromatic amine, that is aniline, is less basic because there is what I am telling, that is there is a less electron density because there is a delocalization of the lone pair of electron over the entire benzene ring. Clear? Due to this reason it will act as a less Lewis basic. So this will have less basic character, C6H5NH2. Then there comes NH3, is very simple. Yes. Now if I compare this one and this one, clear, this one is 1 degree primary amine and this one is 2 degree amine. Now as we know C2H5 has more plus I effect. In both cases there is plus I effect, but here 1 C2H5 and here 2 C2H5. So the I plus I effect dominates here, and we know more the plus I effect, more is the basic nature. So the order will be C2H5 NH2 and C2H5 whole twice NH. This is the increasing order, or you can if you want to arrange them in decreasing order, you will write like C2H5NH, then C2H5NH2, then NH3, then C6H5NH2, Am I right? Yes sir, you are absolutely right here. This is the simple thing you can easily do. Now the next one, the next question is second one. The second one is C2H5NH2. Yes sir. Then there comes C6H5NH2. Yes. Then there comes NH3, then C6H5CH2NH2. Okay. Then C2H5 whole twice NH. Now compare them. First of all, we have to compare this one and this one. We know this NH2 is directly attached to benzene ring, but this NH2 is not directly attached to benzene ring. First CH2 comes, then NH2. It is like this. This is a benzene ring, CH2 NH2. So in this case, that is this nitrogen will have electron density more in comparison to the NH2 atom which is directly attached to benzene ring. Clear? So if I compare this one and this one, so it will have more basic character than this, because I have discussed this, why this will this is less basic, because the electron pair delocalization of electron pair over the benzene ring. Due to this reason, it will have less basic character. So the order will be C6H5NH2. Now there comes NH3. This is simple ammonia. Now come C6H5CH2NH2. Clear? Now compare this one and this one. I have discussed earlier, it will have less, it will have more. Then there come C2H5NH2, and further we will write C2H5 whole twice NH. This is the complete order, my friend. Clear? Similar reason. More the plus I effect. Actually, there are mainly factor: the steric hindrance, the plus I effect. These are the factor which decide the basic character. Now the C part, I am moving here. Check it out. The C part, let me note down once. C2H5NH2. Okay. Then C2H5 whole twice NH. Okay. Then C2H5 whole thrice N, and C6H5NH2. Now tell me which will have more acidic character. And we know if I write like this, it will have, this is aromatic, it will have less character. So C6H5NH2. Now compare. Here is 1 degree, here is 2 degree, and here is 3 degree. Clear here? But the thing here, what we are going to mention, that is, this will have plus I effect and steric hindrance also. This will have more basic character than the 3 degree. Clear? Again I am repeating, this will have more basic character than this one, and it will have less acidic basic character. And similar, let me take the last one also, CS3NH2. Okay. Then there come CS3 whole twice. CS3 have less steric hindrance. CS3 whole twice NH. Then there come CS3 whole thrice N. Okay. Yeah, CS3 whole twice N. Then there comes C6H5 NH2. C6H5 NH2, and the last one is C6H5 CH2 NH2. Okay. Now the order will be C6H5 NH2. Then there comes Yes, then there come C2H5 whole thrice N, then C2H5 NH2, then C2H5 whole twice NH. It will have, because here is a steric hindrance, so due to this reason, and it depends which conjugate. In case of C2H5NH2, its conjugate acid is more stable than its conjugate acid. Due to this reason, it is more acidic than this one, and the two main factor work here, because here the hydrogen bonded dominate, but here due to the steric hindrance there is a less tendency to form hydrogen bond. Clear? Yes. Then we will say the order is C6H5NH2, C2H5 whole thrice N, then C2H5 whole NH2 and C2H5NH. Now I have written CS3. CS3 has no steric hindrance, so the order will be slightly different. If I compare first this one and this one, and they will have less basic character. So the order, this is the increasing order. If anyone asks you to write down the decreasing order, so you can write like this: C2H5 whole twice NH, then C2H5 NH2, yes sir, lone pair of electron, then C2H5 whole thrice N, and then C6H5 NH2. This is the case. Now the second one is C6H5CH2 less than C6H5, pardon my friend. Then the order will be C6H5NH2, yes sir, then there come C6H5CH2 NH2, yes, then comes CH3NH2, then there come CH3 whole thrice N and 2 degree CH3 whole twice NH. This is the order of the basic strength: CH3 NH2, CH3 whole thrice N, and CH3 whole twice NH. Or if anyone ask you to write down in CH3 whole thrice N, then CH3 NH2, then C6H5 CH2 NH2, then C6H5 NH2. These are the order. Clear, my friend? Yes. Now I'm moving here. Now I'm going to rub this part, and let's move to the next question. What is the next question? Let's check it out. Now let's move to the next question. Write the structure of different isomeric amines corresponding to the formula C4H119. Write IUPAC name of all the isomers. What type of isomer is exhibited by different pair of amines? This is a good question. Now what is given here? C4H11N. Clear? Again I am repeating, C4H11N. So this can show 1 degree amine, 2 degree amine and 3 degree amine. That means to say the functional group may be NH2, may be NH and may be N. Clear? Yes sir. So let's draw the isomer. First one is, I have to draw primary amine. That is 1 degree amine. Now draw it. CH3, CH2, then CH2, then CH2, then NH2. Clear? The second one is CH3, CH2, CH, CH3, then NH2. What is the name? That is butanamine, and this one is, that is butane 2-amine. What is butane 2-amine? Now look at, there is a change in position of the NH2. So we will say A and B is position isomer to each other. Okay, position isomer. Now next, if I draw the next figure, we can write like this: CS3, C, CS3, then CS2, then NH2. Clear? Look at carbon 1, 2, 3, 1, 2, 3 and 4, 3, 3, 6 to 8, 1, 9 to 11. Okay. Now what is the name of this compound? That is 1, 2, 3, 2-methyl, that is propanamine, propane 1 amine. So now look at this, is there is a change in the length. So A and C, we can say A and C are chain isomer to each other. Yes sir, definitely chain isomer to each other. Now next, how can you draw the next figure? Okay, I can write like this: CS3, C, then CS3, then CS3, then NH2. I can write like this. Yes, definitely sir. Why not? Now check it out: 3, 3, 6, 3, 9 to 11, 1, 2, 3, 4. What is the name of this compound? If I start from here, 1, 2, 3, that is 2-methyl propane 2 amine. 2-methyl propane 2 amine. Clear to you? Now what do we observe? There is a difference in the length of the carbon chain. So we can say A and D are the chain isomer, or B and D are the chain isomer to each other. So you can easily differentiate which one is chain and which one is position isomer. This is the case for a primary amine. Clear? Yes. Now let's move for the secondary amine. Secondary amines, that is 2-degree amines. Now in 2-degree amine, the first structure will be CS3, CH2, then NH, CH2, CS3. Am I right? Yes. The second one is CS3, CH2, then CH2, then NH, then CS3. These two are metamers to each other. Yes. Now the third one is, we can write CS3, CH, CS3, NH, CS3. Can we write like this? Yes, definitely. This is also a metamers to each other. This one and this one are metamers to each other. Clear? Yes. Now in case of tertiary amine, what is the name of this compound? N-ethyl ethanamine. What is the name of this compound? N-methyl what? N-methyl propanamine. Similarly, you can write the name of this compound. Now this one is, third one is tertiary. Tertiary amines. Okay, this is the 3-degree amine. How to write the name of the tertiary amine in this? How to find? That is CS3, then N, then CS3, then CS3. You can write like this: CS3, pardon, CS3, CS2, and CS3. 1, 2, 3, and 4. These are the total isomer having formula C4H11. N. Clear to you? What is the name of this compound? N-dimethyl ethanamine. Clear? Yes. And tertiary, secondary and primary are functional isomers to each other. Clear to you? Yes sir. Now I am going to rub this part, my friend, and let's move to the next question. Now question number 69. What is the, you have to explain. pKb of aniline is more than ethyl amine. What is aniline? That is the NH2 group. Okay, that is, and what is ethylamine, CS3. That means to say, simply it say that is ethylamine is more basic. What does it mean? Ethylamine is more basic than aniline. Why? As we know, in aniline there is N group which contains the lone pair of electron. There is a delocalization and of this electron over the entire benzene ring. Due to this reason, there is a decrement in the density around the electron density around the nitrogen atom, and it shows minus I effect also, that is C6H5. But in CS3NH2, CS3 group show plus I effect, which ultimately increase the what? The basic character. Simply what I'm telling, aniline will have less basic character than the aliphatic amine, that is the primary amine, or you can say the secondary amine. Why? Because the electron density over the nitrogen atom decreases, because due to the resonating structure, this electron pair moves over the entire benzene ring. If anyone asks you to draw the resonating structure, you can easily draw, my friend, this like this. This one, and this one, this contain NH2. That's why how this lone pair localized over the ring. Look at this, will move here and this will move here. This is the benzene ring, it will move, and here the minus charge, double bond NH2. Okay. Now this one and this one, this will move here and this will move here. Now the third figure will be like this. This is the benzene ring, minus charge here and here, that is NH2. Put here plus sign, put here plus sign. Look at the movement of NH2 lone pair over the entire benzene ring. Due to this reason, it will have less basic character. The next figure will be, it can be written like this. This will move here and this will move here. So we will find here the double bond, here the minus sign, double bond NH2 plus. Now the next resonating structure will be, tell me, this will move here and this will move here. You can write like this, 1, 2 and 3, and here put NH2 again. Due to this reason, this resonating structure, that is, it will have less basic character than any normal aliphatic amines. Clear? Now next question is, ethylamine is more soluble in water, whereas aniline is not. Ethylamine, look at, this is the less bulky group than the C6H5NH2. Due to this reason, it will have a strong tendency to form hydrogen bond easily with water, but it will have less tendency to form hydrogen bond with water. Due to this reason, ethylamine, that is, will have more solubility than aniline. And this is a bulky group, here is a steric hindrance also. So it hinder the tendency to form the hydrogen bond with water. Due to this reason, aniline is less soluble than ethylamine. Now the next one is, alanine does not undergo Friedel-Crafts reaction, because in aniline C6H5NH2, when it comes in the contact of AlCl3. Clear? When it comes in the contact of AlCl3, it forms C6H5NH2 aniline AlCl3. Here this it gives the electron pair. So nitrogen will contain N plus, or it can be written like this, my friend, in presence of Cl2. Better to like C6H5NH plus and AlCl4 minor. This is a strong deactivating group. Due to this reason, there is a decrease in the electron density over the entire benzene ring. So aniline does not undergo Friedel-Crafts reaction. Clear? The next one is diazonium salt of aromatic aniline are more stable than those of aliphatic. Diazonium salt of aromatic amine, diazonium salt, that is the N2Cl, are more stable than those of aliphatic amine because there is a dispersal of positive charge on nitrogen. Due to this reason, diazonium salt of aromatic amine are more stable than those of aliphatic amine. Clear? Yes, sir. Now the next question, let's move to the next question. Give one chemical test to distinguish between, this is a simple question, methylamine and dimethylamine. And tell me what is the methylamine and dimethylamine. Yes, there is a test, that is carbylamine test. Methylamine show positive carbylamine test, but dimethylamine does not. Similarly, secondary and tertiary amine, how to differentiate? That is Lieberman nitroso test. That is secondary amine gives positive Lieberman nitroso test and tertiary amine does not undergo. And how to differentiate ethyl amine and aniline, that is aromatic and aliphatic amine? We know, I have discussed this thing, that is azo-dye test. Clear to you? They form different product with the during the azo-dye test. Clear? So you can easily solve. I am leaving this question, the D part, for you. You can do it with your own. So these are the very simple questions. If you have command over the theory, then you can easily solve the questions. Still, if you have any doubt related to any question, you can come to our website and ask the question. Clear, my friend? Yes, sir. Now, my friend, time has come. In my next lecture, I will discuss few more questions related to the chapter polymer, biomolecules. Clear? Now, time has come, time to say bye-bye. Thank you so much.